So this time we want to see if we can call a function that we've defined in Lua script, and we can call it from native code. So we haven't got any functions in this Lua script yet, so let's just make one here. I'm going to call it foo. That's a thing you do, isn't it, when you're doing examples. I need it to do something. Let's have it call this. We've got a hello world that takes some parameters here. Let's have it so. I think this just prints hello world and prints these 3 parameters out. So let's have it print 1, 2, and then let's pass a parameter in for the 3rd one. I just want to do 1 parameter to start with, so we can like build up to more parameters. So that's got as a function, but we want to call. Let's imagine that we want to call this one from native code. So if I go down to the bottom, after all my this is where the script's been set up. I've, bound everything I need, and then that's executed it's loaded and executed the script for the first time. What we really want to do here before we close it, this would probably be somewhere else in the code when we're doing this normally, but I'm just putting it here for now, and you'll see why later on. I really want a call script function. Whoops, can't spell. Let's call it call script function. I'm going to need the Lua state. I'm going to need the name of the function I want to call and the parameter. So I'll pass in 3. So really, that's what I want to be doing here at this point. And you can see why this is a bit weird, because here I'm kind of like doing something that I'd be doing in my game or in my application. And the rest of this stuff here is more of the actual Lua binding that's generic to everything. And so is this close. So we need to do some refactoring later on and keep this, get this call script function out of here, and just get all this other stuff on its own, so that we can like separate what is like a library and what is our application. But for now, I just need to define this. Let's go back up to the top. I'm going to define it after this toLua function, because I'm going to need this to pass my parameters in. So just after that, I'm going to define our call script function, and I'm going to pass the Lua state. I needed the name of the function, and let's imagine that for now the first parameter is, let's just put it straight in there as it is. So what do we need to do to call a function that's defined in script? First thing we need to do is get the actual function from Lua. So functions are all like first class types in Lua, so that it's just like that function is actually just a global variable. So we just do get global on it. So the name of this function name. So that should get the, we've passed in foo here, haven't we, in our example. So that should get the function called foo and put it onto the stack. And we can assert that with, we can just get the Lua type of the last thing that was on the stack, and just check that it is a function. And if it's not, then we should throw an error. Whoops, we should try to throw an error. And it was function name. So maybe the first thing we should do is, if this builds, we should just test that that works. Well, when we have it, let's give it a function that doesn't exist, and let's see what happens. So we get an assert, but I don't see the error message. So maybe we should just print out there instead, or maybe we do both. But the Lua error there isn't managing to show up. So I'm just going to print that there anyway. Oh, printf. Let's see what we get with. Yeah, unknown script function foo1. So that's probably what we want. Let's put the new line on that. So let's go back to our calling our foo function. So let's assume once we've got in there, we've got our function. It's on the stack. We know it's there. We need to just basically call it, and we can do this with. We need to pass in the number of args. That's currently 1. In this. That's the number of return values. We'll say 0 for that for now. I'm not going to handle return videos in this video, and that is an error function which I'm not handling either. We can just check that that's, if we check that's not equal to 0, that's our case for it working. Otherwise, we'll do the same thing we did down here. We'll do another error, which is unable to call script function. I think it actually leaves an error on the stack. In this case, if you check the Lua manual, this is what their example does. So there should be a string left on the stack in this case with an error in it. So we'll print that as well. I think that should handle that. Now we could probably test that by calling this with no args to start with. Let's just see if that works. Shouldn't be able to call it, I think. It has got in there. Let's see. Number of args 0. It did manage to call that. Let's see if we got into there. I was quite happy with that one. So I need a different way of making that error at the moment, but let's see if I can. Let's try it with 2 args. Oh, actually though, I'm saying, actually I probably can't do this yet because I'm saying number of args, but after the function has been, you push the function on the stack and then you have to push the args on the stack. So let's just push that number on. Let's push that number on the stack. I'm going to say that I can't get it to error at the moment, but I should be able to handle that later on. Push the number X. So I'm saying there's 1 arg on the stack. So we've got the function on the stack, then we've got the args on the stack, and then we're calling it with the number of args. I think I'm getting this. Yeah, that's what's gone wrong here. I'm getting this wrong because that's what I should have been doing. If the result's not equal to 0, then there's an error. Let's try that again. That's where I went wrong, I think. Yeah. Unable to call script function foo. Don't know this Lua type nil. Parameter 2 when calling hello world 3. So it all went a bit wrong in there. But that's good. That's what we wanted. So let's push our number on. 1 argument. Push the argument onto the stack. And then we call the native function. Hopefully, that's the way Lua wants that call to work. So there we go. Hello world 1, 2, 3. So 1, 2 were just in Lua and the 3 was passed in as an argument. So this isn't too much different to what we did before in a previous video. Like this will handle the case where we can call a function that has 1 parameter and it's always an int. But we need to do something a bit better than that because we don't want to keep rewriting this function every time we have to call something. So the first thing I'm going to do is I'm going to template that first parameter. So now I can call this with any number in this t. So that makes it a little bit better, but it still has to have 1 parameter and it still has to be a number because you can see there I'm pushing this number onto the stack. So really what we want is we want something a bit better than this. We want to do something like we did in our Lua because this takes one of our runtime type variants and it just handles putting it onto the stack. So really what we want to do is probably make one of these variants instead and then call this Lua, which will dump the value on the stack and then tell us how many we put on the stack. So let's do that instead. So if we do rttr variant, and our value is called, let's just call it t1. I don't know, that seems to make some sense because this is all templated, so it's like impossible to know what these things are just by looking at the function. And then we should be able to call to Lua with that variant, because this is a function that we've set up before. And the number of args will be, so let's start at 0. And let's just add on the number that we pushed on the stack. So that's going to like create a variant, and it's going to like, these variants, by the way, in this particular RTTR library, this will make a copy. So we're basically passing by value here, and that's something important to remember, that this currently is only going to handle passing by value. It's going to take a copy of the t, which is an int in our case, put it in a variant, and then it's going to take another copy of that and put it onto the Lua stack, ready for it to be used in this argument. So that's really, I think that should be exactly the same code, except now it's a little more varied in that it can accept anything that our to Lua can handle, which currently is only ints and shorts, but currently it will now handle shorts as well as ints. But still we've got the problem that it's only one, we've only got one parameter that we're handling, and we want to handle other cases like 0 parameters, 2 parameters, 3 parameters. We've got lots and lots of other cases to handle. So this is where the C++11 evil comes in to help us, and what we really want to do, what we can do is make this into a variadic template. So what variadic templates does is it just allows you to have a template function that just passes in any number of template parameters. So instead of having one template parameter, it'll just accept as many as we give it. And each time you call it with a different number of templates, it will just make a new function and compile it. So this is going to generate code for us, but in this case it's what we want, because we don't want to keep writing this call script function. We want the compiler to do it for us. So I'm just calling this args in this case, and I have to, instead of passing in the t, I pass in args. You do it like this. The syntax is a bit crazy. Let's call it args now, because now there technically could be more than one of them. And now we want to basically we want to unpack these, and on each one we want to call we want to basically do this on it, on each one of the args that's in there. And unfortunately, to do this, I'm going to have to make another function that can put this on the stack. So basically how this is done is, let's just go for it, because there's just going to be a lot of stuff to do here. So you have to make a function that can just put a single one of these on. So I'm going to call this put on Lua stack, and it's going to take the Lua state, and we want the t to, and this is to be put on the stack. So this can put a single one. We want to do what we did down here in this, which is this code here. This will just put a single one of these t's on the stack, and let's return the number of things we've put on. So this is to put on stack. That's creating our variant, and we're sending it to Lua. So that's just handling the single case where we've got one parameter that we're putting on the stack. But we also have to handle the case where there's more than one of these. And to do that, we're basically doing the same thing, but we want one of these that accepts one, and the rest of the parameters. This will hopefully, I will explain this in a bit, but this probably becomes clearer. But these variadic templates are weird and evil and great all at the same time. So we want the t to put on the stack, and t2 is more args. And what this is going to do, this is going to return, well, we'll put the first one on the stack, which is this. I need the Lua state and to put on stack. And then, whoops, we'll call put on Lua stack with the rest of the arguments. So that takes the Lua state and the rest of the arguments. So let's just call this in here. This function is now going to be called in here, which is the number of args put on Lua stack which is args. And hopefully we can go through this and find out what the hell has this done, because this is just utter stupidity, these variadic functions. So what happens here is this gets called, let's say it's got 3 parameters. They're all packed into this args thing. So there's 3 parameters, 3 different, say, ints, all packed into these args here. When we go in here, we call this put on Lua stack, which passes in again all 3 args to this function up here. But what we've kind of done is we've peeled off the first one on its own, and now there'll be 2 left in this other one. So we've got 1 int in here and we've got 2 ints here. And then what we do is we call put on Lua stack with just the single argument, which calls this one up here. So that just takes our first variant, like the first int, peels it off, and it puts it on the stack. And then we call again this same function, so we're calling ourselves recursively, with the rest of the args, which now calls this again with 2. So we peel off the second int here, and then we'll be left with 1 more in there. So we call put on Lua stack, sorry. It'll call that one again, puts the second argument on, and then we go again with the third one. And in this time, on the third one, there's only 1 argument left, so it calls this one instead, and then puts the third argument on the stack. So if you've not done variadic args before, I suggest you look them up online, but essentially what it's doing is peeling off one of the variables each time, and then it's calling this thing like recursively. So eventually all we end up doing is we're calling to Lua on each one of the parameters, which is exactly what we wanted. And if we, as you can see here, I actually added up the return values, because that's the number of values we left on the stack. So each time we're adding them all up and we're returning them. So eventually we get back the number of args we left on the stack. So let's put my money where my mouth is and see if this actually worked. What did I do wrong here? I'd call template. It's template type name. Template. That's wrong. So let's see if that works. Args parameter pack must be expanded in this context. Oh, and the syntax for expanding this is these 3 dots, which is utterly crazy when you see it, but that's what's going on. I'm passing in those args there, and I'm expanding them out as I pass through to this one, which is going through to here. So hopefully that makes it somewhat clearer if you've not done variadic args before. But let's see what we get. So nothing's changed. It all seems to be working correctly. Hello world 1, 2, and 3. But that's just exactly what we had before. So it looks like nothing's broken. But what this should mean now is, without changing any of the existing code, I can actually call this with 1, 2, 3. Let's change this for X, Y. Whoops. That's a Y and a Z. X, Y, Z. So just to be clear, they've got got one of those with 3 parameters, and I've got one. I'll do one with 2 parameters. I'll just pass the same parameter in twice at the end there. So I've got a foo3 and a foo2. Let's call them both down here, just to prove that it's going to generate the code for us. So this is foo3, and this is foo2, and that takes 2 parameters. So this one's going to call foo3, and you're going to get 1, 2, 3. This one's going to get 1, 2, 2. But I haven't written any new code to do that. No matching overloaded function found for which one? Whoops, I've passed in the name of the function again. So you can see that obviously wasn't being invoked before. It was going straight to that first one, and this one never got called, but now it is, so it's failing to compile. More args. Parameter pack must be expanded. That's me getting that wrong. Remember, you have to do the triple dots to expand it. So that's me getting that wrong as well. And let's see what we get. So there we go. So we got Hello World 1, Hello World 3 gets 1, 2, 3. We passed those in from native, and we've got Hello World 3 with 1, 2, 2. Again, we pass those in from native, and we can do the same thing with 1 parameter or whatever, and it can just handle all the parameters that we handle into Lua. So let's go for that. Let's go for foo1. X, that's the one. Got foo1, So that should work, I think. Yep, so that one's working as well. And the last one that we really want is we want one that has 0 parameters. So let's see if that works. Nope, and that one doesn't work because it doesn't even compile, because this put Lua on stack that we've done, this thing just wants a parameter here. So actually what we want to do, and this might seem a bit weird, is we want one more of these that isn't templated, doesn't have a parameter, and actually just returns 0. So what we're saying here is like put no parameters on the stack, just return me a 0. And in the case where this gets called, where the parameter pack is just empty, it should just call that one instead, I believe, and return 0 args, and then we should be okay with that one as well. Let's see if that works. Unknown script function foo. Did I actually declare it? I didn't actually make one with no parameters. Let's do that. So this would be our last one, and in this one, I'm going to call it with, let's just call it with some random numbers. Not incredibly random, but so there we go. So we're calling hello world with 3 parameters, calling it with 2 parameters, calling it with 1 parameter, and we're calling it with 0 parameters. So that's all handled by this these really strange variadic templates, which these are like really good but also really evil, because when you come back to these after a while, you look at them and go, what the hell is going on here? You need these like 3 functions, and they have to be called from inside this function, and this one's variadic. But essentially it's very powerful, and it's allowing us to do this stuff that we wanted to do down here. So the only other thing I want to do is really I just want to do a bit of refactoring now. Before I move on any further, like this doesn't have return, I'm not handling return values yet, and we can't pass by reference, and we haven't handled passing like our structures that we're interested in and things like that. But I've now kind of embedded, this is what I was saying before, I've kind of embedded application code inside my binding. This is kind of like my binding code. So what I really want to do is kind of like refactor this a bit, just to make this a bit clearer. Really what I want to do is like up from here upwards, up to here. Let's see. This is really the thing that's creating our script and is doing all our automated binding. So let's refactor that out into its own function, and let's have it return the Lua state. So this will be, we'll just call it create script. And what does it need? It needs the memory pool. It wants the memory pool that we're using. So that's that. So this is saying create me a script, and where's that memory pool that you wanted me to use to do it? So that should be. Let's paste that in down there. This should be our Lua state. So that's going to create our memory pool, create our Lua script, and then we've got execute the Lua script. And what we really want to do here is we probably want to break this out into load script, and which takes the Lua state, and that we want to break that down into loading and executing as well. So execute script, because this do string is actually let's put the result on there as well. It's actually doing 2 things. It's like a 2-for-1 deal. You can see it's a macro. It's doing load string and it's doing Lua p call. You notice that actually executing the script itself is the same as calling a function, except you're just calling it without a function on the stack. So that just executes the whole script. And you've got to do that first, because the functions that we want it to call afterwards are actually global values. So we have to execute the script, which creates the global values, which some of them are functions, which allows us to call the functions later on. So let's take this piece of code and let's separate out loading from executing, because this might be something you want to do in an actual app. Is like, you want to create the script at some point, you want to load the script at another point, and you want to execute the script at another point. So let's create all these three. So we want, what did we want? We want to load script, which takes a Lua state, and the script, and we also wanted a execute script. We don't need any parameters, other parameters for that. So that's just that. I believe. I think these just return ints. So just a little bit of refactoring. So instead of that, we've got, we can just put that straight in there. Change this to load and execute the Lua script. Call our script functions. And then we want to close the state. So we'll have one for close as well. Which is just whatever we did down here. Just Lua close. So that's kind of like, this is kind of like the, if you think about it, now what this function is this is kind of like our application now. This is what we'd be doing in our application. We'd be making our memory pool, creating a script, loading it, executing it, calling some functions, and then we'd be closing the script. And we could put this, and we probably should at some point, put this in a separate file, because everything above here is basically our library that allows us to do scripting with runtime type information. And everything below there, this thing, is actually just our test. So let's just put a to do on that. Move this into its own file. This is our test application. So that is pretty cool. And if we did do that, if we did move this into its own file, one of the things we'd have to do is go through and for each one of these functions that we need to call outside, we'd have to like create a header file for it, so we can call each one of these things. And you can see how this would be if you were into the C++ style of doing things. Instead of making these free functions, you could make it a C++ class that could, you could return a script class, and that could know whether it needs to, you could have a load on that and an execute and a close, and you wouldn't have to keep passing the Lua state in, because you could store that inside there. So that'd be quite nice. But essentially, we've built the library that we need to do stuff here. And we've just done a little bit of refactoring there to just point out that this basically would be, if you'd have built this library for someone else, this would be the kind of code they would have to write to do stuff. But let's just see if that still works, if our refactoring has taken. So there you go, it's all still exactly the same as it was before. So that's all pretty cool. We've got some basic being able to call functions by and pass by value with any number of parameters that we can throw at it, as long as they're parameters that we can handle in that to-Lua thing. And we've done a bit of refactoring to like pull out this whole like Lua binding into its own thing, which we could do even more at some point, and we probably should. But that's all pretty cool. So hopefully I'll catch you for the next one. I'm not sure what we're going to do in that, but we've definitely got some stuff to do. We've got return types to handle and other things to do. So I'll catch you for that.